Okay, nomenclature for alkanes. Very important that you understand this material. Be able to take a structure and give it a name, or take a name and convert it back to the structure. You can't do anything in organic chemistry if you can't name these things, or you can't take the name and create the structure. And the rules that we learn here are going to be the basis for the rules of naming everything else. So very important that you understand this stuff. Here's some terms you should know. Now, I'm going to be using nothing but line angle drawings and asking you for those back, because that's how you're going to normally see the larger molecules drawn. You're not going to see someone try to show the expanded structural formula for something that has 150 atoms. It's just not going to happen. So you got to get used to the line angle drawings as well. You know, it's going to save you a ton of time on the exam, as opposed to writing out all those atoms. So let's take a look at this guy here first. We see that there's carbon atoms at all of these sites. And we have to find the longest chain. We have to find the parent chain. So 1, 2, 3, there's 3 carbons there, or we could go 1, 2, 3, or 1, 2, 3. It's all going to give the same name, and feel free to try that. Anytime I say that and you're not sure, you don't see it, try it. But it doesn't matter which 3 that we choose as the parent chain. And that makes it propane. And I'm going to write propane up here just in parentheses, just to remember. So this doesn't count towards the name. It's just I just put it up there so that it's going to be trickier as we, this one's easy, but some of them that we're going to see will be a lot larger, and I just want to remember the parent chain. So now we have to number it. Well, we could go 1, 2, 3. We could number that way, or we could start numbering from the right side. 1, I'll put that in circles. 2, 3. So we could start from this side to this side. Well, you see the methyl group is at position 2 from either side. And this is a very simple one. Don't get me wrong. Like, boy, he seems to think this is tough. Well, but it gives us a lot of information to start off with. So, because we need to find the parent chain, we need to then number the parent chain, and then the substituents that are present, we have to know what they are, and then list them by number. And in this case, there's only one substituent. It's a methyl group. That's what this guy is right here. So we take 2 and then methyl, and that's the only substituent, and then we put in right next to propane, one word. So the reason I put propane up here was because if I put down propane and then add this stuff onto it, I never seem to hit it right. This has to be one word. So, and especially when we get several substituents, I'll never get it right, and I'll have to have a big break, or it'll be all bunched up. So that's the only reason I'm doing that. Now, B, 2-methyl-butane. You have to, it's a lot easier to take the name back to the structure. Butane is the parent chain, so the first thing you gotta do is draw butane. That's 4 carbons. And then, since we haven't put anything on here, this is just the bare parent chain, we can start numbering from the left. It doesn't, we're not restricted. That's what's nice about it. Then we can put on our own the substituents. We have 2-methyl, so 1, 2, done. We could certainly have started numbering from the other side, but since we're now building it up from scratch, we're not tied down to which side we had to start with. We don't have to search to determine what it is. We just start from that side with the naming, so it's a lot easier. A lot of this might not be quite clear yet because we haven't gotten to anything that's really tricky yet, but you'll see. Now, I chose this as our main chain, but you can see that we could have gone here or here, but it will give you the same name, and you're free to try that. You can take this as the parent chain and see if you come up with the same answer as I did. Now, here we have 2 substituents, so we have to be careful which way do we start numbering, from this side or this side. And on an exam, or when I'm proofreading an exam, what I'll do is I'll just number the chain from this side over, and then I'll number it from the other side. You don't have to do this, but this way you can actually, if you're confused on which way to go, name it from one side and then name it from the other side. Those are the only 2 choices. So this one's pretty easy to see that it doesn't matter which way we go, but try it here. If we start numbering from this side, I guess it's from the bottom to the top, We have a methyl group at 2 and a methyl group at 3. So that would be 2, 3, dimethyl butane. If we start numbering from the top to the bottom, we have methyl groups at 2 and 3, so we get the same name. And really, for this, once you get going, you'll see this kind of molecule, this simple kind, won't stop you. But this is a good practice, so you can just get rid of this one. They're both the same. 3-ethyl 2,2-dimethyl pentane. Again, when you have the name, it's very easy. Just write the parent chain. That's 5 carbons. Start numbering from this side or this side, doesn't matter. 1, 2, dimethyl. And then 1, 2, 3, we have the ethyl group, and there's only one ethyl group. And if you had started from the other side, this is what it would have looked like. And you should recognize that those are the same molecules. You can almost see it now that it kind of looks like a little man. You just you take them, legs, arms, head, boom, and it easily matches just by rotating. And if you can just rotate the molecule or bend it without breaking any bonds and to get it to overlap another structure, then they're the same structure. Okay. Now for this one, this looks really complex. If you take if you took this as your chain, then you have this group, and we actually have a common name for this one, but I like you to stay away from the common names as much as possible. And sometimes you'll end up with a substituent that is so complex looking there is no real easy name. That means that you've picked the wrong chain. So we could go 1, 2, 3, 4, 5, 6. And then we'd have this big monster here, and then we have this guy here. And this is actually called a T-butyl group and an isopropyl group. But what if we went 1, 2, 3, 4, 5, 6? Then we're down to just methyl groups and ethyl groups. And that is one of the rules, that you want to have the least amount of branching possible. If you had gone with this central part, then we'd have all this branching here off the sides. Here we just have these nice simple substituents. So on the exam, if a student did that and they used T-butyl and isopropyl, I'd mark it as right. But it's pretty obvious if you pick another 6-membered parent chain, like this one, you get a very simple molecule. So there is some play in that, and but I always want to choose the parent chain that will give us the least amount of branching and thus the simplest substituents. So from here, I'd start numbering 1, 2, 4, 5, 6. And you don't have to do, you can just eyeball it and figure out which one is the best. But I like to, especially when I'm teaching it, number from both sides, just so that we can take a look. Now, from the left side, we run into substituents at site number 2. From the right side, we hit a substituent at number 2 as well. So what we're supposed to do is we number from the side that leads us to the first, will get us to the first substituent fastest. So we just have to go 1 carbon in on each side, or 2 carbons in on each side to meet a substituent. So now we have a problem. We're meeting up with substituents on both sides. But there's 2, at site 2 here from the left, there's 2 methyls. From the right, there's 1 methyl. So which one would you think would win out? Well, we have to choose one, and we want it to be some standard that everybody can go by. Well, then we go with the one that has the most substituents. If they were the same substituent, then we'd have to keep moving down the line to find something different. But in this case, there's 2 methyls and 1 methyl here, so we go with the left side. We start naming them, and this would be, we have ethyl groups at 3 and 4. So we have to name those first. 3, 4, diethyl. Remember, okay, well, let's finish this up. And then we have 2, 2, 5. So we have 2, 2, 5 tells us where all the methyl groups are, and there's 3 of them, so trimethyl. And it has been pointed out that the 2 numbers here tell us that there's 2 ethyls, so we don't really need, it's kind of redundant to have the di, and there's 3 numbers here, so that should be, we know there's 3 methyls, so the tri is redundant. That's okay though, those are the rules. And if you did notice that, that's great. It's good to ask these questions, and there we go. Now, for the next one, 3-ethyl 2,2,3 trimethyl 4-propyl heptane. So look at the very last, the parent chain, get that done first. 2, 4, 6, 7. And then you don't have to number them like I do here, as I said, but I just do it so that you can see what how I'm approaching this. So we have, I start from the left. And at this point, it doesn't make a difference left to right, but once we start putting the substituents in, then we have to pick a side. So I started from the left. So we have 3-ethyl, and then we have 2, 2, and then 3-methyl. Should have left some room on. I didn't see that we had a methyl group that was going to be on here. That's why it's a little slanted. And then 4-propyl. 1, 2, 3. And so the name to the structure, you should get those pretty quickly, but the structure to the name can always be pretty tricky for some of these guys. Now look at this. Should be pretty clear that the main, or the parent chain, is this. But if you don't see it, just keep going. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Just keep going around, and you'll eventually find the longest chain. And now the numbering. Well, I'm gonna do like I've been doing, number from both sides, just so you can see. So there's 8 carbons, so that's octane. I'm gonna number from this side too, just so that we can determine what's what. So if we start numbering from this side, they're both on the left side, so I have to say this time, the top side here, we run into a methyl group at number 3. Here we run into a methyl group at number 2. So this is the side where we run into a substituent first, so the circled numbers are the correct ones. Now there's 8 carbons, so it is octane, and they're all methyls, so forget about the uncircled numbers, we have to go with this one. And yeah, it's a little messy, and just, I'm just doing it for you to see. You don't have to do this. Only if you get really confused, you might want to try that, try numbering from both sides. So we have 2, 4, 5, 6. There's 4 methyl groups, so that's tetra, methyl, octane. And I forgot to check, but I don't see any other groups. 1, 2, 3, 4. We got all the groups. Good. 4, 4-diethyl, 6-methyl, 5-propyl nonane. Just stop right there. You need to know these base names. Nonane is 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm not going to put the numbers in here. I would just start from this side. So 1, 2, 3, 4, just to save some time. Methyl. Then 1, 2, 3, 4, 5, 6 methyl. 1, 2, 3, 4, 5 propyl. And if you have a handle of this, you should, for this one, pause now, get the name, and wait, and then let it go forward so you can see what I've come up with. So this is the main chain, and you're free, again, you're always free to try a different chain and see. Either you come up with the exact same name that I did, or you'll come up with a name, a shorter parent chain, something will be different. It's either you're going to come up with the same exact name, or you'll come up with something different, and that different one should be pretty obvious once you've spelled it out why it's incorrect. So 1, 2, 3. But always check. This is heptane. I just want to write this out just to remember. 1, 2, 3. Now, I could number, but I want to keep these videos under 20 minutes, so it's pretty easy now if you really put some effort into these molecules. You can see that we have, if we start from this side, 1, 2, we run into substituents 1, 2, 3, 4. So obviously we don't start numbering from this side. So it'd be 1, 2, 3, 4, 5, 6, 7. I hate to use that word obviously because professors used to use that on me, and it's not obvious, but it should be. The more of these you do, the easier it will be, and it is very straightforward, if not obvious. So we have from this side, we run into substituents first, so we just start numbering from this side. So we have 2, 2, 3, 3, 4, 4, and there's 6 here, so this must be hexamethyl. They're all methyl groups. Heptane. That's a monster. That's out there, so that's good. But if you can do that one, all set. Notice I've gone to nothing but structures to names because these are much tougher than names to structures. So this one, 1, 2, 3, 4, 5, 6, 7, 8. It'd be 8 if we gone down there. So either way, either chain will give us the same name. And you don't have to put these dots on the carbons. I'm just doing it so you can see how I'm counting them up. So 1, 2, 3, 4, 5, 6. That's octane. Now from this side, 1, 2, 3 at the third carbon we meet methyl. 1, 2, 3, third carbon we meet ethyl. So a methyl at 3 and an ethyl at 3. This side wins out alphabetically. This would be 3 methyl, but this is 3 ethyl, so this we have to start numbering from this side. So it'd be 3 ethyl, 6 methyl, and then what does it say? Octane. And we have to put the substituents in alphabetical order. And if this was a 6 for the ethyl, it would still be, the ethyl would still come first. It's not the numbers, it's the names of the substituents. Okay, this guy, 1, 2, 3, 4, 5, 6, 7, 8. So octane again. Now at carbon 2 from this side, we meet the methyl groups at 2. We meet a methyl group at 2. Since there's 2 methyl groups on carbon 2 from this side, and only 1 on this side, we start numbering from this side. So this would be 2, 2, 7, trimethyl octane. Now let's see, 1, 2. Now I'm going to make this an ethyl group, just so that we have a difference in the, and then let's put a propyl group here as well, just to give us a little tricky one to do. Now, so it looks like the main chain is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is decane. I'm just going to write that in parentheses so I remember. Now, if we start numbering from, and this one, and we have the time. I just noticed our time was getting a little short, but we have time to do this. If we number from the left to the right, we have these we get 1 to 10 here. Let's do from the other side with the circled numbers. And so from the left side, we run into a methyl group at 2. From the right side, if we start numbering from the right side, we run into a methyl group at 2. That doesn't help us. So we keep moving down the line. From the left, at site 5, we run into ethyl, an ethyl group. From the other side, at site 5, we run into propyl. So ethyl is the lower, it has a, alphabetically comes first. So we start numbering from the left side. Because the methyl groups don't help us, we keep moving down, we run into ethyl and propyl. We run into ethyl first from the left, propyl first from the right. Ethyl wins out because of alphabetically. So we have to go in this direction. So ethyl is alphabetically first, so we put 6 ethyl. Then we have methyl and propyl. Now that means that we do 2,9-dimethyl, and then 5 propyl. And then this is decane. Where are we? Okay. So a couple of things. Note that we put them in order: ethyl, methyl, and propyl. This di, even though that D it comes before E, we don't look at the prefix, only the letter that started off the substituent. So we don't want to worry about the prefixes. So still dimethyl comes after ethyl because M comes after E, and propyl comes last. And notice the numbers, we didn't worry about those at all. We have 6 first, and then 2 and 9, and then 5. They're not in any particular order. We go alphabetical order. And that's it.